Hi, Annie and Luli. I'm trying something new for your video, so let me know how it works, okay? I'm gonna be sharing my screen so we can review a keynote, explaining and having more pictures for your lesson on ignition, okay? Okay. I'm just gonna, I don't know if I can, oh, okay, I can make my face bigger so we can see my explanation, okay? This is your lesson for rocks on the Earth's surface. Okay, and for your introduction, let me explain this. The Earth's crust, the layer where we stand on, it's mostly made of rocks. In most places, the rock on the Earth is covered by a layer of soil. You know, soil, it's that mix of dead and plants organisms with rock, little rock itself. Soil means tierra in Spanish. So remember, it's made of organic material combined with little rocks, and rocks are underneath everything, underneath oceans, lakes, rivers, and underneath even the polar ice caps, even though you don't think about it that way. And you can see many layers of rock. If, for example, you are traveling on your car, you're driving with your mom and dad, and you see when they cut a road in the middle of a hill or a mountain, you can see all of the different layers. Okay, or if you see a canyon or a cliff. Let me show you some pictures, okay? This is where you see, this is the ocean and you see the rock underneath. This is soil as you know it. And in this picture, you see, these are the layers of the Earth. You see the inner core, the outer core. This is the mantle. Watch over my cursor here. And this, let me move my face. This small layer here, the outside layer, it's the crust. That's what I'm talking about, the crust, rocks on the crust. And these are some pictures. This is a picture of a river with some rocks underneath, and this is the soil. And it shows you how this is the plants, where the roots, this is the soil, and under all of the soil that you usually see, there is a bedrock, really hard rock, and that's part of the crust too. We are gonna review some vocabulary with you girls, and I have some pictures as support, okay? So for the first word, it's aggregates, agregados. Means a clustered mass, like a mass, a group of little different particles held together, they are together. Rocks are aggregates of mineral, meaning that rocks are groups of different minerals put together. Then we have the word cleavage. It's the way or direction in which something split apart. It's how something breaks. And I have a picture here that shows that different minerals break in different ways, usually like really pretty and geometrical ways, but some minerals are the exception. Then we have the word element. An element, it's a substance, it's something made from just one type, one particular kind of atom. For example, gold. You know, if you have a gold earring or a gold bracelet, gold, it's an element. So a piece of gold, it's made of a lot of atoms of gold. We have different things, different names for elements. Here is the periodic table of the elements. It's a tool that scientists or regular people use to learn the elements and see information about them. Then we have the word luster. Luster means brillo in Spanish. It's the degree of brightness or shine on something on a surface. And they use it when you're talking about minerals to explain how much they shine. Like this picture, you see that this rock has a lot of luster. Then we have the word mineral. In Spanish, la same, mineral. It's any chemical substance that forms naturally in the earth. And I have a picture of really pretty minerals here. Okay, so for rocks and mineral, most rocks, well, rocks are mostly aggregates or combination of one or more minerals. Different rocks have different minerals producing different types of rocks. There are about 3,000 minerals, but only about 100 of them are really common. Examples of common ones are rock salt and or benzoylite, for example. But examples of rare minerals are gold, silver, gems. That's why they're expensive, because you don't find them everywhere. Let me show you a picture. These are rare minerals, like gold. You have gold here, you have silver. These are some examples of gems. But here you have really common ones. Like this is pencil lead. It's what you use inside of your pencil to write. Comes from a mineral, and this is rock salt. It's a type of salt that you use for your food, like pink salt if you eat it at your house. Okay, so the people that study minerals are called mineralogists, okay? And they describe minerals in this way. First, you have some rules. First, minerals have to be found in nature. They are not man-made. People didn't make them, God made. Okay, another point is that minerals have the same chemical makeup wherever you find them on Earth, meaning that if you find gold, it has to be chemically the same as all the gold that you find in different parts of the Earth. For this reason, sand, the sand that you see on the beach, it's not considered mineral because it changes from beach to beach. That's why you see in a beach like white sand and it's smaller than another beach where it's, for example, brown or black. Another point is that atoms of a mineral are arranged in a regular pattern and form solid units called crystals, okay? So minerals make up crystals. Crystals have special forms and usually they have flat sides called faces. Most of them have 6 faces, but some can have even 8 faces, okay? And another point is that almost all minerals are made up of substances that were never alive. Some are exceptions, but have to be things that went from living things to minerals over many, many, many years ago, okay? Living things contain minerals, but when these living things like animals or plants die, the minerals go back to the earth. That's part of the chemical cycle. The Bible explains it in Genesis 3:19 when it says, "For dust you are, and to dust you will return." A bone, it's not a mineral, but it contains mineral. That's, for example, what happens in fossils. Remember that a bone would become petrified if it filled with all mineral, but a bone, it's not a mineral per se, just contains minerals. And many minerals are actually elements you find in nature. For example, copper, iron, tin, gold, zinc. All of these minerals can be found in rocks. And laboratories help to identify minerals, but you can identify them also by color, by luster, by streak, which means rayas, stripes, and also by hardness or by cleavage. Remember that cleavage is how something breaks or split apart. Now, let me show you some pictures of different material. This is copper, this is iron, and this is silver, okay? So remember that some minerals are actually just elements, okay? That would be it for the class, girls. If you have any questions, let me know. I hope this worked today. Bye, girls.